Welcome back, everyone, to this special session. I think it is the first time we do that in the Legacy of Socrates. Instead of having a talk now, we're going to have a discussion. And so we will have Adi, who is usually in backstage, who will be here and participating. And we're hosting Jessica Kerr, also known as Jessitron on the internet. And together we will be talking about legacy code, but you can also participate. You have ask a question below the video. So if you do have questions, don't hesitate to put them here. I will keep an eye on the chat. I will keep an eye on the questions, and I will cherry pick some of these to, bring into the discussion. Now, a bit about Jessica. If you don't know Jessica, you're missing out. You can hear her a lot on podcasts, blog posts. She's talking a lot about legacy code for sure, but something called Semanticity, and we're gonna dive into that in a moment. But this is the kind of concept when you first hear about that, you're like, what is this about? And then when you learn about it, you realize, how I've been missing that. Like, it is totally my situation. I know totally what she is referring to, and she can give me advice to help me every day on that. So I'm really excited that we're here to discuss together. So welcome, Jessica. Hi, Adi.
Thank you.
And I'm going to kickstart the discussion just with this question. So I mentioned something called semanticity, and I'm sure people here, they don't know about semanticity, not all of them. So can you explain what it is about?
Yes, semanticity is one of my favorite words now. This is a word coined recently by Nora Bateson. She's an anthropologist. And a semanticity is a learning system made of learning parts. So there's lots of systems in the world, they're everywhere, but some of them are more mechanical than others. Some of them hold still, and you could hypothetically study them and understand them fully. But other systems, such as us, our teams, ecosystems, the economy, will never stay the same long enough for you to understand it thoroughly. Because the system as a whole is changing, because the parts are constantly changing and learning from each other. So in ecosystems, different species evolve to fill their different niches, and they react to each other and eat each other and stuff. And in our teams, we're constantly learning from each other. As a software developer, I think the interesting bit is you would think that software is one of those systems that would be mechanical enough that we can understand it completely if we just look at or work on that learning far enough. We should be able to get a complete grasp on legacy code. And yet this is not the case, because the software systems are also learning constantly. I mean, some faster than others. Some code is actively, like, we're like deliberately changing it, and it's learning from us that way. And then even code that you don't change, new vulnerabilities are discovered, and so the world is different, and so that code is interacting with the world differently. Platforms are sunsetted, and you have to run it somewhere else. The new version of Java drops, and this one's out of long-term support. Software doesn't stay the same either. So our software teams form a particularly interesting semanticity, because I include the running software in that system bound. It's learning from us, we're learning from it when it throws exceptions and stuff. And of course, we're constantly learning from each other as well. When we look at it that way, I think it brings both hope of what we can learn together, and also kind of a release from the expectation of ever understanding anything. Ever understanding everything. That's not even a thing.
Yeah, that's I can totally relate with that. And I think something very interesting in what you're saying here is it's not just about the software. It's also the system. So, for example, the company we're working with, the team we're working with, the individuals who are here, and the communication between everyone. So, in that sense, how does this concept really can apply to us working on an existing system? Like, does it have any impact more than just a relief? Can we use that knowledge to make things improve?
Yes. So if you think about you and the software and the system growing together, then there's kind of two major categories here. One is you were involved in writing the software to begin with, and you kind of grew up together. I think of it kind of like a forest. In a forest, like a natural forest, not like a planted for harvesting trees forest. The trees grew up together at different rates. Their roots are all intertwined, and there's fungi mushrooms underneath the surface, intertwining all those roots and passing messages back and forth. And all of this, the forest is a semanticity in the sense that the fungi is passing messages back and forth between the trees for like what pests are here. Are we going to seed this year? Because they all do or they all don't. They like reach an agreement on this somehow. They don't make all their seeds every year. So there's this like network that you can't see of the trees talking to each other. And if you just cut down a tree, some of that knowledge is lost. If you drop a new tree into the forest, I'm just going to plant this tree here. It's not in that network. And it's a very different experience. So when we talk about legacy code, usually if we look at legacy in the sense of the challenges and sometimes negative associations of I'm working on a legacy system. I personally love legacy systems because they have value. I'd much rather be there than on anything that's not currently in production. But when you look at that, it's like being a new tree planted into a forest. And it can take years and years for a new tree to tap into that root network and fungi system where they can exchange water and nutrients and generally like be part of it. And it's like that as a new developer dropping into a team. It's going to take time. But the trick with software is that as a learning system, we change together. So the way to learn a code base is to change it. You can, one trick I learned from my friend Ben was you can refactor some code, but when you refactor it, maybe it definitely needed it, or maybe you just like had the accomplishment of confirming that yes, it really works like this, and it makes more sense to me this way. But then all those other trees, all the other developers on the team were used to it the old way, so you can throw that refactor away, and you still gained the understanding. You have tapped into that piece of network. Yeah, there's a connection between understanding and changing. That it's really hard to come to understand a system without changing it and thus like sort of integrating yourself in your own brain.
Yeah, that's it reminds me of something because a technique that is often overlooked when you're working with existing code is to do some exploratory refactoring, so allowing you to change the code, as you said, but not to necessarily to ship that refactoring, just to like get engaged with this code, put your hands inside it, and so understand how it's working, and then at the end you throw away these changes because they were here, so you get to understand the code, how it works, etc. That connection you are mentioning. And when you are doing so,
like that.
Yeah, when you're doing so, it's relieving because you don't necessarily need to maintain the system working, etc. You can just go crazy and try things. But yeah, you're connecting. Adi, do you have some experience with like that kind of exploratory approach or working with teams and
Yeah, I think one of the exploratory methods that I was using a few times was the Mikado method, but I think in a way, in a bit of a different way than I would rather go it from an evolutionary design point of view. So I'd like to see the paths, because I think typically the Mikado method is used just for legacy code. But I guess you can use it also for exploring design options. I think that's a very interesting approach, and it relates a lot to Semanticity, because in a way you are learning about the system, but while you're changing, in a way, there's this reaction, like you with your team, with the code base. So you are all learning together, and it starts becoming a complex system. I think all these methods of trying to explore the code, like probably the Mikado method is the best well-known method that has a name, is a very good approach to look at the code from an evolutionary point of view. And I think also what I wanted to say is that this applies a lot to complex systems. I don't think that it makes sense to talk about these kinds of approaches if you have a simple system. So probably, as far from my experience, the level of change and the level of semanticity in a system increases while the complexity increases. And by that, I can say the number of the team, or the size of the team, the size of the product, how many lines of code you have, how many customers you have. The more of that, the more product owners or business people and so on, the more it becomes more difficult to understand what's going on. And I think looking at semanticity makes sense. But if you have a small product, I think it would be kind of too much in a way. That's my experience.
yeah. So
Oh, go ahead, Nicolas.
oh yeah, no, it got me thinking. Yeah, sure. If the system is very small, maybe it can fit in your head, or your team also is small, like you're only 2 or 3, then it's not much of a problem. But I've experienced different size of teams and different size of software, and it's funny how you don't realize when you pass the threshold when your system is growing at the point where it cannot fit anymore in your head, and you need to realize that.
Yeah, and it's very nonlinear. It's like say there's a program that you work on and you understand the whole thing, which is way easier than coming to understand a program someone else wrote. But it's not too complicated, and it's not too complicated, and you add more, and then you hit that point in the nonlinear curve where it just goes whoosh, and then it's too late. But yeah, once you hit that point of accelerating complexity, every little feature that you add, oh, now it needs to log in with Facebook. Oh, now it needs to accept new customers with this format, or then everything starts to affect everything else, and all the features start impacting each other. So sometimes it gets to a factorial kind of a complexity expansion.
Yeah, totally. And also the human factor. I mean, I'm working in a startup now. So let's say pre-COVID, the way it works is that every 2 or 3 years you raise fund, and now you have a lot of money. So you decide to, double the size of the engineering team. And so you hire 10 more people, and you're only 10 at that point. So you want to be 20 by next year. But when you're doing that, you're also making the system much more complex, because it's not just about the code base. It's about all of these new trees you're planting. And I don't know, Jessica, if you have advice, experience, like how to handle that kind of growth, but in a more maintainable way, sustainable way, maybe.
Yeah, it's tricky because as the complexity of the software increases, you need more people so that collectively you can hold all of it in your heads. Our limitation is how much we can know. And as a team, we need to be able to know at least something about and be able to find out more about all the different parts of the software. So you have to add people. But every person you add adds complexity too. And there's this overhead, and Michael Nygaard calls it the coherence penalty of adding more people and keeping everyone in sync. And that there's that nonlinear factor there too. And there's a reason that like we wind up breaking into teams of like 5 to 8 because the only way to deal with that nonlinear growth and complexity is to increase the number of people, of features, whatever, is to stay at the low end. So as you get to 20 people, you need to like spawn. 20 people is like up here on the curve, and you need to break into a couple teams of 5 to 10, and then you've added a layer. Oh my God, hierarchy. Yes, hierarchy is completely essential for systems, or some sort of substructures. You don't have to call it hierarchy, but it is. You don't have to treat it as hierarchy with respect to authorities, but it's there. So you have to create those boundaries, and those boundaries aren't like strict. There's still, you've got 2 teams of 5 to 10 now, and there's some interconnection between, I don't know, the forest on the left side of the hill and the forest on the right side of the hill. But they interact more with each other. Or how do I say that? Each team interacts more amongst itself than between. And that keeps the complexity of those interactions from scaling until it takes up all your time. And then there's like domain-driven design where you actually enlist the code to help that communication instead of having to develop more communication to compensate for the code being too abstract or confusing.
Yeah, there is kind of a parallel to do with how the organization evolved and how you structure the people inside the organization within sub teams, as you said. And the more you grow, the more boundaries you need to create. Abstractions.
I had a good point about the past too. I think you mentioned wanting to know about the past as well.
Yeah, there is this notion of the past.
Yeah, because the systems got this way for a reason, and even more interesting, they stay this way for a reason. Yeah. Usually it's because some other piece of the system is adapted to the way it became, and so it works together. And like hearing stories is really helpful as you add new people to share stories, so that it's not, oh, why is this so terrible? It's, oh, that this was a really quick or effective solution to the constraints at the time. And we're going to change it at some point, but not now.
I think you don't need to be very judgmental. In fact, when you look at legacy code, that's one of the big advices I give everyone, because maybe that person is you as well, and someone else can say, why have you done that? But you know the context in that case. And I think that's very important, not to get too connected with being judgmental to people, but trying to look at the context. And this applies every time when you have a complex system. Look at
exactly.
whatever is going on around, and then decide what you need to do. Because maybe it's a bad solution, but in that context, it's a good one. It happens.
Yeah, and how do you, so that's for the past, but how do you prepare, how do you change the way you do things today So the future is better because this, if you continue to grow, this problem will be more and more present in the future, and maybe eventually you will move, you will quit the company for some reason. And so how do you prepare today? What can you do? So in the future, it is easier for the people, to connect with that.
Right, because sometimes the trees get cut down and moved to another forest. I really like commit messages because, I mean, comments have pluses and minuses, but they do get out of date. A commit message is never out of date because it's attached to a point in time. So that's one thing I do.
Adi, do you have?
And
Oh, sorry.
pairing and ensemble programming so that it gets spread around.
So you offload the knowledge into the team brain, like collective knowledge, and there is less risks that the whole team get down than an individual. So that's indeed a good thing in terms of.
Yeah, if the whole team that's moved on, they've given up. They don't want good software.
Yeah. That's interesting. Adi, do you have it?
Well, I look at two things: implicit knowledge and explicit knowledge. Typically, by implicit knowledge, I mean the knowledge that people have, their memory, or they know where to find it very fast. But also
they don't know they have.
Yeah. So, but also something very explicit, especially for things that are very important. Like when I work with architects, I really like to tell them to create guidelines. So if we have a sensible part in the system, use these guidelines. And every time I try to refactor a legacy code, and I know that because of the architecture, because of performance or security, you have a sensitive part in the system, I try to create a guideline. And that means it's a very short kind of living documentation because it exists in the code, but you point it to there. And the architect should make sure that that part of the code remains like that as an example of how things should be. So that's a very good idea, also related to living documentation, not necessarily something that you write on a document that nobody reads, or something that you put on a drawing. But I think that's my approach, typically trying to go more and more towards living documentation. Especially with big systems, you need also diagrams. You need to understand where you are and the zoom levels where you are. So I think where I learned, and I talked a lot with these two people about living documentation, Simon Brown, who uses Structurizer to create diagrams from the system, and then Cyril Marfer, who wrote the book on living documentation. So it's about how to create on all the levels, even on how you name your namespaces and how you structure your tests and how you put them together in such a way that they don't create friction when you look at them. And I think these things are extremely useful when starting to restructure legacy code. It's not only about the code, it's also about how you put it in your IDE, how you put it in your namespace, how you create the new containers or the new components or the new systems if it's a very big system. And then how you point out to look, I've made now an example. This is how I think the others should be like. And in a way,
what should be?
Sorry?
How you think what should be? I missed the word.
I don't know.
Ah, dang it, internet.
I think it's an example.
Yeah, an example, I think I said.
Oh, okay, thanks.
Sure.
Sorry, my internet's not perfect.
Yeah, no worries. Ours isn't perfect as well. So, yeah, so you create an example and then everybody goes back to that. And I think that in this way you can scale a bit a change in the code. And with a lot of, pairing or ensemble programming, as you said, or code reviews and architectural reviews, you can change the things a lot faster. So first you create a kind of guideline and then you spread things around. That I think is extremely useful also to create that living documentation for the future.
Yeah, you have 2 points in there that I thought were really important. One was about the Zoom level, because I kind of feel like that's one of the core challenges of our work is understanding why we're doing this at all and how we've broken it into pieces in those boundaries, and then all the way down to the tiny detail level of what are we going to type next. And the ensemble programming and pairing helps with that a lot because then you have more people to think it different levels.
Yeah, for sure. But I know that in the agile world and in the world where things are beautiful, people look a lot on working together and having these mobs, and the mob always knows everything. But in the world where I live, with big corporate and very old code bases and businesses that need to strive to be on the market, to push out, you cannot have that. So you do need some overhead of documentation. You will have overhead of management. You will have inefficient processes. So you need to work with that. And that's why I think documentation is needed, and you cannot rely just on people, because I don't know, maybe some HR person makes a stupid decision and then 2 teams leave. What do you do then? So that's why I do think you need implicit documentation as well.
Yeah, because a lot of companies don't realize that software that's running in production is alive, and it needs to be alive in the heads of people, or else that's my like kind of worst definition of legacy code is software that doesn't live in anyone's head. There's not a team on the other side of it, so it can't adapt to the changing world. But companies don't understand that yet. They think that you can have a capital project and put software in production and then you have it.
Yeah, I think people still think in projects, and I typically working with big companies or big products. I tell them you should stop thinking about project, because the project stops and then maybe you have maintenance and not much happens, like a bridge. Okay, how much do you need to work on a bridge after you open this? Maybe you paint it every
on the Golden
few
Gate
years.
Right. There's some bridges, like I've heard that the Golden Gate Bridge, there's a team that paints it, and they paint the whole bridge and then drive to the other side and start painting it again because it's like it takes them like a year or 2 to paint the whole thing, and by that time it's time to paint it again. So they just have one team that's like nice and stable and stuff.
But it's
smaller bridges probably have a team that paints a bunch of bridges.
It's still repetitive work. It's not that there's some changes, the market changes, you need to make new features. There's a lot of context change, and it's extremely difficult to work like that. And I think while the market becomes more agile, I think you need to keep even more of these structures in place, and you need to keep your people there, because I think the complexity increases. That's what I saw in the last 10 years. The complexity of the market increases, and that generates complexity of the product, and that generates complexity of code.
The market, because as software allows companies to change faster, companies change faster, which means the market changes faster, and then you need to change the software faster.
Exactly. So that's a very interesting example of Semanticity. So that's a very I think.
The market is totally a huge synonym. Yeah. Totally. That's true. I'm gonna write that down for my systems thinking workshop.
Something I like to do in that situation, and it goes to what Jessica mentioned earlier, like the commit messages. I like commit messages also because they take a snapshot of what was true at that time, back in time, and that was true at that moment. And so the challenge also with documentation and good documentation is to keep it up to date, and there is this whole living documentation thing. There's a book about that. I'm gonna drop the link in the chat in a moment. But what I want to say is snapshot of what was decided and why, and what was the context. So in 1 year, you can remember, you can refer to that and learn what was behind that kind of decision. And so this is called architecture decision record, but really you can call that whatever you want and use the format that you like.
I use commit messages as little tiny ADRs. Like, yeah, okay, I know this isn't great, but it's a step in the right direction. So hopefully we'll come back to it later. Kind of
yeah, this is why. And that has been proved useful. So we started using that in my team, and it's starting to spread outside of the team to the whole company, and people see value in that because first it's cheap to do. Like what we're asking you is just to get that out of your head, put that in a markdown. It doesn't have to be long, but at least put a bit of content. Just explain why it is the way it is. You are making that decision today.
Tell the story.
Sorry?
Tell the story.
Yeah, tell the story. So you cannot be wrong. Just tell your story, and then in the future, someone else joins and wonders something, and oh, that reminds me this story in the past. Okay, there you go. You can read that, and at least you have more context, and that helps. That helps.
I like that. You cannot be wrong when you tell the story.
That's true.
I was working with the team, and they never had information about what happened and why. So they had these, I think I could call them like the witches of the tribe who knew everything that happened in the past.
Wow.
There were a few people who were very old there in their organization, and so nobody knew why something happened or how it was, but everybody went to them to ask them. And it was weird that they were in all the projects from almost all the organization, just because nobody or the company didn't have this culture of recording their decisions. And you had always this situation that I was going in a meeting, and for 1 hour they were thinking why they have done that and discussing and say, we've done that. And then, yeah, but then we decided against it. But then we decided to do that. And that was for 1 hour, just getting the context. So looking at that, I know how important decision or marking your decision, these snapshots are very important just because of that. If you have a very long type of product, and some organizations will have that. So yeah, you can look it also from the other way around. What can happen? What could be a bad situation, or what is bad when you don't make these snapshots in whatever format? It can be architectural, it can be commit messages. I don't know. It can be a story. It can be anything, but you need them, I guess.
Yeah. When you don't have that, it's easy to make the assumption that people were idiots. which just means people were in a situation that I do not understand.
Yeah, exactly.
Adi, you brought up something about like guidelines and examples of how to do things and that spreading. There's a tricky bit with legacy code of how do you trade off gradually upgrading toward the latest coding standards and the latest patterns and the new language constructs and stuff like that, which sounds like a great idea, but there's also consistency, and consistency has value. And if you have a code base that's slowly changing and you're like, okay, well, it started out in 2005 and then we've modified it ever since. So, look, this code looks like it was written in 2008, and you just get like every standard, and that's it. How do you trade that? How do you decide how to make that trade-off?
Well, typically when I was working on legacy code, most of the legacy code didn't have any standards, so it was a mess. I didn't have
no consistency anyway.
Well, the only consistency was that it was a mess.
Consistent inconsistency.
Exactly. Yeah. So I'm coming from that world where the code was so bad. I guess just in a few situations it did happen to me, and we just chose one of them. We chose one of the standards. We chose one of the standards.
Okay.
So probably there were 2 or 3 options, and all of them were in the code. So then we said, okay, this is the guideline for now. Let's use this, and we all agreed on that. I guess if you have more than that, it doesn't make sense. It's a mess. So if you have more than 3, 4 standards, already it doesn't matter anymore. You just need to.
You might as well invent a new one.
Yeah, make things better. Exactly. It's like with the JavaScript frameworks. Just invent a new one.
Yeah. Well, JavaScript is a good example because it's changing very frequently.
There are so many JavaScripts.
Yeah, I think first, as you said earlier, standards, they tend to be implicit. People have different styles that come from different backgrounds. And so making at least the team standard explicit, it's a good thing to do. So at least everyone converges towards a consistent way of doing things. And not just for coding, really, for the way we do things as a team. So that's the thing I try to do first. And then when it comes to your question, like there is this legacy code with maybe a mix of different styles, and we have decided to go to a different style now. How do you trade off the consistency versus we want to get there? And it's too big. You cannot do that in one shot.
Okay.
Yeah, that's exactly the situation we're in my team today. So the way we're doing it is we have documented where we want to go. So we have created a refactoring .md file in the project to track, okay, this is the patterns we have today, but we really want to go to that pattern because of yada, yada, yada. And so we're saying that it's going to take a while, but at least we have this reference of this is a decision we have taken and this is why. And so anytime we have the chance to go through the old patterns, we migrate to the new pattern. And for example, we have
so we still have. We're going to touch it anyway.
It depends. Generally, yes, we try to be opportunistic. So it's only when we need to touch it that we actually change it. Sometimes we might take some budget to spend time. We call that sustainable weeks. We take a week once and then every quarter to just do that kind of work. And for example, we still have a mix of TypeScript and JavaScript code base. And our decision is to migrate progressively towards type because it has proven very useful for us. But we still have JavaScript code that we're running into. And what we do is when we run into JavaScript code, first we convert it to TypeScript, and then we resume to the work we were doing. That's how we do this in my team.
Before you change the JavaScript, you convert it to TypeScript.
Yeah. That's an example. Right. I also noted that I read your blog post and you mentioned that so in your team, Jessica, you're using Slack and you have a channel which is called Jessitron Stream. I don't know if you're still doing that, but that you're using that channel as a notebook for yourself, but it's open so people can follow that. And is it something you still do? And can you tell us more about
that? Not right now, because my current chief clients, you don't just create channels for free there.
Okay.
It's too big. But whenever I'm at a company of like under 1,000 people, I like to create a channel. I call mine Jessitron Stream. At Atomist, which was small, we were like 30 people. A lot of people copied that, and then most of the company had their own stream where you can use it to just paste stuff to yourself, to paste the errors that you see and cursive things. But then also whenever I have a question for someone, I can post it in my channel in context with the other stuff that I've been complaining about. I especially do this when I don't have a pair and I wish I did. Just chatter at myself in Slack. And then when I tag someone to it, ask them to come into my stream, then they can see it right there. And also anybody could join and follow along if they wanted. This is kind of nice. Our engineering manager was in everybody's stream. Now, I don't recommend that he worked like 23 hours a day somehow. I'm not. No, 23 is an exaggeration. It was 21.
Yeah, well, that's huge.
I don't recommend that. But it just makes, when we're all remote, it's a way to like not feel as alone. There's stuff going on, and I can go poke into other people's streams and see what they're doing just when they happen to post something. It also, I like having the different granularity of different channels. There's like, this one's just for me, and I'm going to post as much as I want. This one's just for CI server, and it's going to dump a bunch of stuff. This one's for our team. This one's for the whole company. And so you get less and less frequent posting as you go up in scale, because more and more people would see it. Yeah, I liked that conscious use of Slack.
Yeah, that's a very good thing. I might try that, because we're still trying to find good recipe to all of us working remote, which is not something we were used to do. And something you miss is space to, like offload your brain, but also give the opportunity to others to jump in if they want to connect, like opportunistic connection. That's something, that's something you miss when you're not working with the others. You're not having a coffee chat, and I know companies are trying to simulate that.
So much.
So yeah, that's okay. I'm gonna try that definitely. Okay, I'm gonna check. There is no question from the chat. We're hitting over the end of this. It was great.
I like that someone says the channel sounds like a public rubber duck. Yeah, I think that's a good analogy.
Yeah, that's true.
That's true. It might even help you debug things.
Yeah.
I think I was doing a bit the same, but with Google Documents. So I was writing down stuff and then making that document public. Typically, but that wasn't generic. It was more like assessing a situation or a code base or an organization. So I was putting their information rough and then starting to distill it until it had a form. And that form I would present to everyone.
Yeah, thank goodness for Google Docs and Miro and these tools that let us work on something together.
Yeah.
Definitely. Okay, well, thank you very much for this. Thank you, Adi. Thank you, Jessica, for participating. I hope that was entertaining. And I hope that also, I hope also people got some ideas from our little chat here. We're gonna have a small break before our next, I think, final talk. So David will be talking about unit test as specification in a moment. Stay tuned. And in the meantime, I encourage you to go grab a drink, walk away from the computer, and come back later.